Oh, thanks. All right. Yeah, this will be a relatively short one. We are mid-progress doing a major transformation, deprecating most things DBT and, well, at least on the computation side, BigQuery, towards a SQL Mesh Trino pipeline, where we are exporting from Trino to a variety of new places. And yeah, do you want to start, Javi?
Sure. Let me share my screen. Okay. Window and here. Okay. Cool. So, well, first of all, I want to share the new matrix metrics dataset that we have. So basically, we are, as Ray say, in the middle of a rewrite. We are like transitioning from DBT into SQL Mesh. And basically, we have set up a different process of the pipeline that runs all the metrics in SQL Mesh. So one of the tools that I've been writing is an exporter that basically exports all of the data from SQL Mesh to BigQuery so that people can use it. It is this metrics schema, and we have all of these different data sets. So for example, we have all the artifacts by collections. We have like artifacts by user, all the artifacts themselves. Then we have all of these key metrics, which are ones I've been working on, which basically give us like some metrics that are like overall time. For example, all the amount of repositories, all the amount of stars, all the amount of pull requests, so that in one place you can get all of these informations, for example, for a specific artifact or for a specific project, so that you don't have to like query everything and do all the joins together. We are computing all of that for you. And then we also have the time series metrics. So basically, you can just use that today, which means that this is openly available now. And as Ray say, we are still in the process of rewriting everything, but this is some data that it is now accessible, and that's running on our pipeline. And the second thing I wanted to share is, I want to present this one. Yeah. So basically, I am, well, I just finished one really cool thing, which is these two different decorators. The first one is DLT parallelize. So basically, this allows us to take any DLT asset, whatever it is, whatever it does, and basically split all the processes that it does, like all the fetches and all the computations, into chunks. And then we asynchronously process that, giving some configuration like the chunk size, all the parallel batches, and the wait interval, so that we can actually process and choose how fast, how quick, and in which way we want our DLT pipeline to run. Because in the end, a DLT resource or a source is just a decorator that yields. But we don't have a lot of control over this because everything is hidden in the library itself. So by using these tools, we're able to like exactly tell how much we want to run, in order to, for example, squeeze the right limits so that we are exactly doing the maximum that we can per token, for example, for GitHub. And the second one is basically this process chunk resource. It is used like this, which solves the issue of having really, really long-lasting jobs that sometimes fail, for example, in the middle or in the end. These processes cost a lot in compute. They are like really expensive, and we don't want to fail at the end and retry. So basically, this function automatically splits all of these resources. So basically, it's generic for resources, and it does some checkpoints and uploads the data to GCS. And then on the event of a failure, it basically downloads back the manifest, see where it was, skips everything that hasn't really been processed, and continues updating data. And then at the end, it just processes everything that it did. So with this, we will be able to, like, for example, put our different resources and sources in spot instances to like make everything cheaper. And we will lose less time. And it also has a really cool thing, which is, here is the max data age, which basically tells us how fresh we want the data. If we want to, for example, run this every week, but we want to just like, change the data if the data is older than like 2 weeks, maybe we don't want to run it like all weeks, but we don't want to like, have a different process of our pipeline. We can just process it here. And this like handles everything for you under the hood, all of it, and it's pretty simple to use. Just have to like, instead of yielding the resource itself, just have to return or like yield from this function. And these are the arguments that will be passed to like the other functions. So yeah, it's all dynamic and it's wiring up all for you. And I can actually show it in progress because I was actually showing it earlier. So I think it's this one. It is the also testing bucket. Yeah, this one. So basically, if we go here and if we go to this one, this is how it looks. So first of all, it will like fetch all of the data, and then it will say, okay, I am updating the state with these pending entries. So basically what that will do, I will make it a little bigger. What that will do is that it will go like chunk by chunk, and it will update and send all of the data in that chunk to GCS, and it will let it there. And then it will also pass a pointer, like sort of like a checkpoint to, hey, okay, I've already processed the first 80 entries. In case that it is restarted, it will take this into account. Don't process all of them because they're already on GCS, and continue. And then at the end, it will delete all of the data and it will upload it. So this basically allows us to not lose our information and make this error resistant. So yeah, that's what I wanted to share.
Quick clarifying question on the max data age.
Mm-hmm.
So if I run this job every single day, will it wait until after it's older than max data age?
So for the moment, max data age is a parameter to check like how fresh the latest manifest is. So whenever you run this the first time, it will create a manifest with like all of the data that you want to like feed into the resource and a pointer like where it is. Imagine that I run this today and I forget it there, the snapshot is there, the schema is there, and in 2 weeks I want to run it again. What this will do is it will use the all data, but since I passed the max age, it will just like delete it and start with a new one. That's how I like saw it. But if we want to do as I said, it's like it works. But yeah, that's the main use. I don't know if I like the question.
Yeah, so let me get this straight. So basically, if I run it again, it will skip anything that I already have that's within the max data age, and only get the stuff that I'm missing. But if it's older than max data age, it'll delete. Delete. Got it. But if I run it to completion and it succeeds,
everything's fine.
And then I start running it every day, and everything's within max data age. It'll just skip and won't do anything, right?
So no, it will actually run again because like when you like finish completion, it will clean everything up. No more state, no more everything. But if we want to do that, how to say that functionality, it's as easy as not deleting the manifest at the end. So that will mean that if it's like less than max data age, it will not fetch anything, not do anything. But then when it is like more, it will delete and start again. So it is like a super trivial change. But for the moment, it is like every time it reaches completion, it wipes everything.
I see. Okay. Yeah, it's just a little bit, the behavior is a little subtle because it basically means it will skip and just resume if there's been a failure and the manifest is still there. But if it runs to completion, it will just, it'll refresh everything, right?
Yes.
Okay.
That is for the moment. So I'm taking suggestions yet.
No big deal. I think just understanding it. I mean, like I'm positive I'm gonna forget that I even asked this question. So it's probably worth like documenting this in a comment somewhere at the very least. And then yeah, we can decide how we want to change the behavior later. But okay, cool. This super useful. At the very least, worth commenting somewhere that this is how it behaves.
Perfect.
Cool. Okay. I can demo a couple things real quick. The first thing is really simple, is in our data portal. We now have an OP Atlas dataset, which you can subscribe here. And it is basically any data from OP Atlas project registry that is, designated public. So for people that want to start doing some data science against all things retrofunding, this is going to be a useful thing. It should, effectively give you access to organizations that are defined in OP Atlas, projects that are defined in OP Atlas, and then all the project artifacts, including deployer addresses, website links, GitHub repos, stuff like that. We are still in the process of wiring this up. So a couple things that I'll just tease. One is like, yes, all things DLT factories are transforming how quickly we can replicate data sets. So this is all it took to replicate all their tables, which is super cool. Javi's work expands on that, which is also super cool. I will also share that we're still kind of wiring these things up. So our pipeline is now under metrics mesh models. And you'll see that we now have a staging model for the OP Atlas work, which is where we're basically gathering all project data, all contract data, and all repository data from OP Atlas. It's just a staging model right now. I still need to wire it up and connect it to the rest of OSF directory to create multiple project sources. But soon enough, this will be, there will be an OP Atlas project source, which is really nice. And the last thing I was going to demo is this seems like a subtle change, like on but it's a pretty big one in the sense that the API now, we've completely shut off any copy jobs from dbt BigQuery to ClickHouse, and it's all coming from SQL Mesh Trino now. So these are all models that were computed relatively recently on our SQL Mesh pipeline. Again, powered by ClickHouse, but it's coming from SQL Mesh now. And yeah, these are relatively up to date. So feel free to use the API. I think the one that is most interesting that people might find useful is this contracts v0 is powered by the new superchain datasets. So we enumerate all contracts deployed by a particular root deployer address, and you can basically gather all contracts that root deployer has produced. So that's super useful. And it's probably the first job that we do where we kind of index the entire universe of addresses. We're going to start doing more and more of that kind of stuff in the future. But yeah, this is all accessible. And as Javi mentioned earlier, it's also accessible in BigQuery because we do copy the SQL Mesh work back up to a BigQuery data set. Yeah, that's it. Short and sweet. Do you have any questions, Javi?
Nope, seems pretty clear. I liked it.
Cool. Yeah, I'm down to keep this one relatively short today. I think there's still a lot of resilience, fault tolerance, ironing out the edges, all things of our new data pipeline. So it's all things quality, fixing bugs, and fully deprecating out the DBT pipeline that we had. So yeah, that will be a continual work, and we're going to be at ETH Denver next week. So feel free to reach out if anybody is going. Cool. Thanks, everyone.
Thank you.